Okay. Hello, everybody. Thanks for staying here because lots of people left already. I will introduce a little bit SIP3 project, which is one of the newest, maybe, solution on the market for analyzing voice over IP, SIP, and all the stuff. The plan is to talk very fast about myself, about SIP3 project itself, about technology, and especially about use cases. And I will show you the demo. Okay. This is something dangerous again. Kind of Wi-Fi issues, right? Okay, let's do it like that. So, my history in telecom and voice over IP was begun almost 20 years ago. 20 years ago, I left my university and became to be engineer in a GSM company. In that time, not too much voice over IP technology was penetrated on the market, but I've got an order to do a research of it. Anyway, it was first time I was in touch with voice over IP technology. 7 years later, I was began to be part of Hewlett-Packard, and there was an open call already mentioned during this conference, and there was open call media platform, which was not actually my main point of work in the company. I was managing SCP telecom support, but anyway, I was aware about how it works, what is SIP, RTP, voice XML, and other stuff. Well, after that, after I left this fantastic and big company, we have started very small, and we implemented web calling technology. One of the previous speakers already described you some kind of JavaScript stuff and so on. In that 2009, there was no JavaScript, and WebRTC technology was just starting. We used Flash to create web calling. It was everything: presence, messaging, phone book, voice call, video call, everything. But the market was not ready. It was made for our customer. Market was not ready, and the project it was stopped already. When after that, I spent some time in other companies starting some kind of VoIP-based IVR and everything for GSM. It was used Kamailio and FreeSwitch. And now we are running SIP3 service troubleshooting software project, and company named the same. To get you a little bit more about SIP3 history, the project itself, it was started like delivered through the consulting. It was custom development for our customer. And after a couple of years, we noted like it is successful, and it could be replicated and used for the rest of the industry. So we incorporated SIP3.io company, and we made our first version of open source Tapir product, which was not actually very, it didn't create a great, let's say, penetration or a great number of followers. So we closed it up again. We full-timed our engineers, and we did a huge refactoring. And now we started go-to-market. We participated shows. That is why I'm here. So we work for SIP trunks, service providers, communication as a platform, service providers, contact centers and cloud centers, service providers, as well as carriers who run voice over LTE, because it's very SIP-based and a lot of stuff needs to be done here in terms of monitoring and calculating metrics and everything. So we are going to help also unified communication industry and enterprise and manufacturers as well, like SBC manufacturers. So about the stack, we all know OC level 7 levels model of the network communication, and the most important thing in our understanding is the service part, because for application performance management, for database management and containers, operation systems and networks, there are a lot of very good tools who are in use on the market. So we decided to focus here, and there is 3 parts: call control SIP, media controller TCP, and media RTP. And that is not the end of the story, because on top of that we have user experience and business effects. For example, your voice service is not running good, so it affects on user experience, and users left your company, so business taking risks. So about technology. In general, there is an amount of components. First is most important, it's a probes. Probes are taking information from the network or from the network nodes. Network nodes, I mean everything: SBC, software switch, media gateway, IVR, platform, whatever. Then we need to aggregate all the information collected from the different legs of the call, do something with it, store, send, or whatever. Then we need to correlate, and sometimes correlate before send, okay. And we need to visualize it, yes, thank you. So in terms of software component of our solution, we have main 4 components. There is a captain, and you can install as many captains as you want through the whole your infrastructure. There is a salto. You can have several saltos who will aggregate and do something with this information. You have also storage, like you can choose one. We recommend you to use InfluxDB and MongoDB, and flexibility and scalability is on the databases. And correlation mechanism and visualization mechanism is done by server side and client side. It is Twig and Hoof components. This picture represents the overall architecture. So collected data through captains go to Salta. Salta can receive as well third-party sources and push information to third-party monitoring, Datadog or whatever. Or then it can store information about the calls itself to MongoDB and metrics information to InformixDB. Twig is a component which allows your users, business users or partners to integrate with the system, and Hoof is what's loaded like React software which is running inside the browser. So about the product methods, probe methods. We have started from pickup files. It is not our priority now, it's just working. It's just a usual situation when a service provider runs some kind of environment, some kind of pickup files are written in the loop and collected somewhere. So we are ready to start with these pickup files and show you the map of the call or whatever. I will show you later. We also support Oracle SBC CDRs, or we can support any kind of special CDRs you have in the network. It's subject to discussion. We support SPAN port, which is mirroring port on the network equipment. It exists on most of the equipment, or maybe on all of the equipment. And for high load cases, which is, I don't know, 600,000 packets per second per interface, we recommend to use TAP, which is port mirroring, like optical mirroring on Ethernet level, so you don't have any active equipment between. You just receive a copy of the whole traffic. And we spent a lot of time to implement it, and it really gives us results. And thanks to the PDKA. And we as well support Homer protocol to collect, so you can easily integrate all your favorite things like Kamailio, free switch, asterisk, or RTP engine, whatever. For huge infrastructures, for worldwide distributed infrastructures, there is a way, there is a kind of sketch how it could be organized, like, collecting information and storing into database, and if you have multi-site, worldwide presence, 2 sites in Australia, 2 sites in Europe, 2 sites in China, 2 sites in, or I don't know, 8 sites in United States, you can organize the whole and consistent network of the data collected for each and any call. So, about use cases. The first value we brought to our customers is just to short up and speed up the time of processing customer claim. Before we came, our first customer had a kind of 2 engineers taking through TCP dump, through pickup files with some kind of scripts, trying to understand what's going on. After we deployed the solution, it takes just 2 minutes. It's not takes just 2 minutes, it's 2 minutes, but you spend it by front end in call center, in customer care, not by operational specialist. So you can imagine you not just save time, you save a lot of money, because you can use your expensive time of your specialist to some kind of architecture or whatever tasks. What was our objective to implement the solution is to create really simple and useful, user-friendly user interface, and to create it as simple as possible. So this is a simple search. And if you will not provide any kind of number you want to find, you will find all the numbers, all the calls, and exact state of the call and duration of the call. If you select one of that, you will filter all this massive with a very fast way. It took like a couple of seconds or less to go through the huge amount of data. Each of the call you found, you can check with the details to understand how it was served. If it was successful or not, you will see like in what stage of the call it was a failure. And clicking by any kind of method you have here, you will have detailed like everything about the call. SIP3, ISAP encapsulation is supported, so we will decode it and show it as well. We do not limit size of the history storage by any kind of licensing. So it depends. It really depends on you, on your choice. If you have what kind of amount of traffic you have, what kind of history you need to store, and it's easy to calculate how much disk you need to make it stored. And everything continued to work very fast with a huge amount of data, and it's always comfortable to work with us. So we not just save register invite history, like calls history, we also store register history, register method, and we implemented like separate history depths for different methods, because if some kind of customers have problems with registrations, it's usually 1 or 3 days, or you can keep it for a week. And for invites for claims about calling, you will usually want a history like in a longer, I don't know, months or 3 months, whatever size you prefer. Second, we decided it's not enough just to show these troubleshooting things. We already have information about all the calls on the network, so we decided to implement metrics, service metrics, calculation and storing. It is calculated in real time and showed to the user interface in real time. All this with open REST API, so you can use Grafana natively from Influx, or you can use our interface, which is more simple, more friendly for, or ready-made for end users, or you can connect through the REST API to any kind of your enterprise storage of the metrics. So some examples of the metrics. You can see here like call setup time. If it's growing, it's obviously not normally. And your customers probably unhappy, and probably some kind of issues are existing in the network. You can check it with your favorite monitoring system of the database or whatever disks. Call trying delay is quite important in terms of quality of the service, because if you call somebody, you prefer to hear the answer as fast as possible. That's also about user experience. We collect, I don't know, something like 20 metrics, but it could be grown to 100 metrics per each node, per each trunk, per each direction of the routing. And for network itself, it's of course overage when we aggregate it to the network. But you can easily understand what is the successful rate for the metrics. And you can understand if your network is now working or not, or was it working fine in the night time or day before on the weekend and everything. Traffic, as well as you insert probes on your infrastructure, you can easily understand what kind of customers, what kind of SIP trunks generate what kind of traffic, how much of the traffic, and you can easily go and understand what is the quality of the customer itself, and what is the quality of customer service provided. On this graph, you can understand the following thing, like with the blue one, it's call attempts, and with the red line, it's answered calls. So on the left, you have a customer who are actually a good customer for you, because most of the calls generate real paid call. On the right, there is a kind of maybe bad customer who use a lot of resources of your network and generate not too many calls compared to what the call setup and rest of utilization it's provided. But if you will go to see to the scale, you will understand like this bad customer on the right is not just let's say bad customer, because absolute amount of paid calls is much higher than on the left side. So it's not just technical data, it's of course technical, and you can, let's say, optimize your infrastructure based on this data, but it is data for your marketing colleagues and for your business colleagues to understand customers better and to provide exact attention to the exact customers. So one of the cases is the fraud detection. How it works? It is on the graph. You have the number of successful and failed registrations, and you can understand if failed registrations is growing, there is some kind of fraud should occur in details. You can go search for the method state method register, state unauthorized, and get exact IP address of the bad guy who are trying to figure out correct password for kind of different numbers. It could be automated, of course. We are in the beginning of the story, but you already have this possibility. Another case is the identification of a problem for trunk or infrastructure or even specific node. With a growing number of state failed metric for specific node, you can understand, and in the same time with a going down success ratio of the calls in the network or in the trunk or in the node, you can understand like there is some problem. And okay. Well, and you have use case when something in between two connected partners, there is a problem of communication, and each of the network admins say like, okay, everything is okay on my side. Another party peer say like, okay, it's everything okay on my part. And you need a kind of document that will show that something going on wrong or right on party of the call interrogation. So you have a possibility to find exact call on the call history, to be sure very fast on the web interface like it's the call that was claimed. And you can download pickup file, which will contain all the logs, all the exchange, and you can send it to your partner and solve an issue. Well, this is another case in cloud service providers. When you have a lot of nodes and nodes handling a lot of traffic, you can have statistics about how it's utilized. If some nodes become to reject calls or it successfully manage calls, and based on this information, and based of growing number of calls, you can set up more virtualized resources to handle these calls. And when call setup intensity goes down, you can stop the nodes just to save money. It's okay if your machines are quite light, I mean in terms of CPU usage and memory and resources, and you do not pay so much check to your Amazon or Google as a provider. But if your infrastructure is requiring a lot of resources, you need to manage it right, just to avoid huge checks for nothing, without serving customers, paying your cloud service provider. Well, what else? What else you have with our solution? You have clear picture of what kind of customers you have. For example, on this example, there is a mobile operations, like mobile users are connected to them using this service, and you can see easily iOS versus Android, who are the customers actually. And more than that, you can have a detailed analysis of the versions of your software is used on the customer side, because you know, like this App Store and Google Play Markets, you publish update, but customers are not updating, and you can find how it is actually looks like, and even you can find exact customers and communicate them if you like. So demo, I hope we have network now back. Yes. I think I need to do something like that. Okay. There is a dashboard with the metrics. Whatever it is, it's just a demo, call duration, success ratio, and everything. Then, as I said, you have simple search, which is most probably useful for marketing ladies or whatever guys involved on the front of the customer. You have also advanced search, which is more like Wireshark styled search string, and usually engineers prefer this one. I don't know what is it, but okay, if something nothing with that. You can filter like this. You can check what was the call history. You can save it as PNG file, and you can use it for like communication to your partners or departments. You have details of the call, like for each of the message. Okay. And you can export to pickup file and use Wireshark to check what is there. Exactly. So that's basically it. That's
just in time. Thank you, Konstantin, and thank you for the demos, and I'm glad to see new cool software joining the VoIP world in open source space. Any kind of question, Benjamin?
Just a small question. Do you have any plans to include RTCP or MOS values?
Yep.
From the RTP source you have already?
Yes, we have RTCP is implemented. It's on the testing stage. We are now in a high-load testing, accepting a huge amount of traffic and processing it. And RTCP will be public in, I don't know, 2 weeks or months. And RTP is following. Yeah.
Okay, I'm just interested to know what kind of requirements do you have to correlate all the call legs of the call?
Good question. Actually, we was started in an environment where no exact header was traveling through the network. So the only way to correlate legs, it was a task to create a kind of language to describe what is the call legs correlation rule should be applied to find exact legs. Because you're right, each of invites could be received several times. Time on all the nodes should be synchronized. So to make this correlation working, it was a hard task we solved. But in reality, we face like a lot of networks have a kind of network header which is traveling through the whole the path, and it's much more easier.
Okay, thank you so much for coming and sharing with us all